wind.
The sun emits what's called a solar wind, tenuous particles streaming out from the outer parts of the corona. And basically, it fills our solar system. The bubble of solar wind that permeates our solar system is called the heliosphere.
The edge of the heliosphere proves that the true power of our sun isn't found on its surface. It extends way out past Pluto. As the solar wind bursts out of the sun's atmosphere, it whips past the Earth at 1,000,000 miles an hour and blows by Saturn and the outer planets in just a few months.
Solar wind is blowing through the universe.
Near the edge of the solar system, billions of miles from the sun, the solar wind slows down abruptly. This point is called the termination shock. Here, the wind is colliding with matter from outside the heliosphere, becoming denser and hotter. And as this phenomenon continues beyond the shock, it creates a scorching layer of hydrogen gas. Far from any star, yet unbelievably hot and powerfully charged. But what causes the temperature to spike? Astronaut Mike Massimino and scientist Steve Jacobs are about to unleash a 250-gallon shower on this platform to see.
All right, Jake, where are we here? What is this thing?
This is an excellent model.
So when the solar flares and the gaseous
and there's interesting phenomena that occurs at the edge.
Go way out in the solar wind.
We're going to drop water down in here.
And then it finally starts to collide with matter from
When
outside
it hits the plexiglass is similar to what happens as solar wind spreads
creates more
throughout the solar
hydrogen
system.
and
it starts to build up. It interacts with the plexiglass and makes a little wave, a sheath, a circle, and we'll see it.
All right, how do we get this thing to work?
I gave you that magic box.
That's what this thing is for? Are we going to be dry down here?
Let's find out.
Here we go. Armed and fire. Whoa! Look at that. What are we looking at here, Jake?
Well, that dot represents the sun.
That's the sun right there.
The water transferring out, that represents the solar wind, and the particles inside that wind are traveling 700,000 to 1,000,000 miles an hour. And they start to slow down out here, and when they interact with charged particles out there, they bunch up to slow down and impact with them.
Okay, and that's where we see it getting red again.
And that represents the shock right here where they bump into each other.
And how hot is it getting around here?
200,000 degrees. It actually heats up there.
But that's kind of almost counterintuitive that as you're closer to the sun, you expect it to be hot.
Right.
And as you get further away, the zone out there warms up again. Why is it so hot there?
Well, the same phenomenon that happens in the sun when particles are forced to interact and rub together. You know, they will emit radiation in the form of light, which we see, and heat.
And heat, kind of like friction.
Like friction, kind of like friction, yeah, friction.
It's interacting.
It's a neat model, right?
It's cool, but we're just looking at this right over our head. It's a representation of our solar system, and we're getting to look at it right here.
The power of our sun is truly amazing, stretching far beyond any planet. But it's not even close to being the biggest star in the universe.